राजेश पटेल सर डीन है कि प्रिंसिपल है?
Very good morning, students. Uh, uh, so, uh, in previous class we end the chapter number 1, that is the diffusion. End this chapter diffusion. So we finish the introduction of mass transfer. We finish the N and J type of flux. We finish fixed flow of diffusion. We finish the study molecular diffusion. We study the diffusion of A on diffusion of B. We see the effect of temperature on diffusivity, and so majority of the diffusion uh, chapter number 1 is finished. Now, instead of going to this big chapter number 2, interface and mass transfer coefficient, what we finish? We finish first theory of mass transfer. So we will finish film theory, we'll finish penetration theory, we'll finish surface renewal theory, we'll finish boundary layer theory. We'll finish first, then we go for chapter number 2, and after chapter number 2 we'll finish heat, momentum and mass transfer analogy. So we'll study like this. First we'll finish this theory. First, in theories of mass transfer, we finish this core theory. Then we understand chapter number 2, and then momentum, heat, and mass transfer analysis we will study. Then we go for chapter number 4, 5, and 6. Then, so first I would like to first we'll start the theories of mass transfer. Then we go for the uh, uh, interface mass transfer and mass transfer coefficient. And so let's start with the theories of mass transfer. And so chapter number 3. We'll have chapter 3. And chapter number 3 is theories of mass transfer. And today we'll take, we already discussed it, but again we'll start within the film theory. Again, we'll start within the film theory. We'll start within the film theory. Yeah. So let's understand the film theory. Okay, so in film theory, we said that the concept of boundary layer. In film theory, we said the concept of boundary layer. So in another words, what we said in previous lecture, for examples, we have a solid material and the fluid is flowing in a turbulent flow. Fluid is flowing in a turbulent flow. So whenever the fluid is flowing surrounding the particle, there is a boundary layer formation will be occurring. So one invisible layer will be formed, and there is something happen in layer. So here the boundary layer comes into the picture. So whenever there is a uh, turbulent flow is there, at that time we have to calculate the flux using one concept, that's the mass transfer coefficient K multiplied by concentration difference, or mass transfer K multiplied by pressure difference. So concentration difference when liquid will come a picture, and pressure difference when gas phase come into the picture. So to calculate the mass transfer coefficient, it's complex thing. So we have a tree theory, and using the tree theory we can predict the mass transfer coefficient, and that mass transfer coefficient have a relation with DAB. So different theory have a different relation between mass transfer coefficient DAB. So we can predict the mass transfer coefficient using these theories. And once we know the mass transfer coefficient, once we know concentration difference or pressure difference, we can calculate the flux and that is the ultimate goal to calculate. So that is the things, uh, 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 this is the ultimate goal in today's theory. So first we'll see film theory. First we'll see film theory. So let's start within the film theory. So when a fluid flow, when a fluid flow turbulently past a solid surface, and mass transfer occur from surface to the fluid, from surface of the fluid. So what is the scenario? I would like to tell. So that is the scenario, like anyone heard the naphthalene? There is what one like there is one solid naphthalene ball is come. So you will keep it in your bathroom, in your wash basin, you put it in a white it's circular, like white color, one on the thumb naphthalene ball, that will be the naphthalene ball. So for example, the naphthalene ball will be there. I think you will heard it. Yes, one student says Aryan, so he said that phenyl nigodi. Yes, Aryan, it's a completely right. In Gujarati language, they say the phenyl nigodi. We'll say we go to a grocery store and we say that phenyl nigodi. Yes, that's a naphthalene. So we have a surface solid surrounding. If we give a force of air, so air will be go from surrounding, and naphthalene concentration will transfer from solid to the fluid. And you will see once the time decreasing, or once the time goes from around 5 to 3 days, that naphthalene ball will be sizes decreases. તમે જોજો, I am saying in Gujarati, જે બી ગુજરાતી પસંદની જોજો તમે ત્યારે બી મૂકી હોય એને વોશ બેસિનમાં કે કોઈ બી ટાઈમ જોજો એ નાની નાની થતી જશે. It means કે what will happen, there is a mass transfer from that naphthalene ball to the surrounding fluid. the transfer of mass from naphthalene ball to the surround fluid. What will happen? Naphthalene ball having a highest concentration of it, and once it going toward the fluid towards lowest concentration, so mass transfer occur from solid surface to the fluid. Mass transfer occur from solid surface to the fluid. So what will happen? There is a concentration difference from the solid phase to the fluid phase will be there. So if the flow is if I'm giving a fluid with some velocity, for example, okay, I'm giving a air around the naphthalene, we have some velocity. So here some boundary layer formation will occur surrounding the fluid. So here boundary layer occur, the concentration is decreasing in the boundary layer, then it goes to the bulk. So there is a concentration profile will come into the picture, and that concentration profile will be the look like this. So here is a naphthalene ball. Here is a naphthalene ball. I am drawing like this. So I am representing this one is a solid, where there is a concentration of naphthalene. Now we are giving a air. So because of air, there is some boundary layer occur, and here is a bulk air, and which is having a turbulent flow. So what will happen? Here concentration decreasing, and then it goes toward the bulk of air. So here concentration Ca1, here concentration Ca2. So due to the concentration difference, mass transfer will occur, and here one film is occur. We call it a film, and film having thickness delta. So what will happen? So film theory is a one type of model that it's a one type of prediction, and that predictions will that prediction will helpful to calculate the mass transfer coefficient. So in film theory, uh, due to the concentration difference, uh, uh, concentration difference between the film and there is a thickness of the film. So film theory predicted that Na is equal to DAB divided by the thickness of the film multiplied by Ca1 minus Ca2. And once we compare this equation with this, Na is equal to mass transfer coefficient K multiplied by Ca1 minus Ca2, we can say that K is equal to DAB divided by here film thickness. And the one thing is that it's difficult to calculate film thickness also. It is very difficult to calculate film thickness also. But this is the relations to find out the mass transfer coefficient with diffusivity and film thickness. So this is the one approach from the film theory, and film theory is used to calculate the mass transfer coefficient K. Okay? So uh, let's calculate one example based on this theory. This is the theory, and let me calculate one example based on this theory. Before going to that, there is one MCQ question will be there that I would like to share with you. Can you give me the answer of this question? This one will ask in GATE 2000, GATE 1997. According to the film theory, mass transfer coefficient, mass transfer, according to the film theory of mass transfer, the mass transfer coefficient K is proportional to d square d raised to 0.5 and 1 divided by d, where d is equal to molecular diffusivity. What will be your answer? Can you write down your answer in chat box? Mass transfer coefficient A.
બસ મેં કર્યો
કહું એટલે કર્યું તમે
બીજી આવતો
સાહેબ હું તમને શું આપણે માસ ટ્રાન્સફરની મેન્યુઅલ ખબર હશે તમને
મેન્યુઅલ તો અહીંયા લેબમાં નથી પડી
આપણે માસ ટ્રાન્સફર
તો એના જો કહું છું ઠીક માસ
હા ઈ છે પડી તમારે
એક તો એક ટ્રાન્સફર
તમને ખ્યાલ છે કે યાદ હતું
એની હું તો આટલે બધી શું કરતો સોફ્ટ કોપી આપું છું સોફ્ટ કોપી
સોફ્ટ કોપી હોય તો ઈ આપો
એ પડી બધી મારી
તો આ પેલું ઓલું ડિફ્યુઝન વાળું હતું
હા હા
શેર કરશો okay the answer I am getting from students so first answer will be the by Bhaumik and that's the diffusivity DA option. Aryan is saying 1 divided by D option. Abhibai is saying A option yani D A 24 number A Tefera A and answer is diffusivity D. Now the correct answer is A, diffusivity, molecular diffusivity D, because mass transfer coefficient K is proportional to the DABD. So the correct answer is A. A, it means K is proportional to the K is equal to D. And this is the correct option. Now I would like to give another option, another question, and that's the mathematical question. For that, I would like to write down the example in board. Let me write down in board. Diffusion rate of ammonia. This is also asked in GATE exam. Diffusion rate of ammonia from an aqueous solution to the gas phase is 10 raised to minus 3 kilomole per meter square into second. Question mark, finish. Okay. Can anyone unmute themselves and tell me what you understand in this first sentence? Can you imagine these things, whatever writing down in first sentence? Anyone would like to try? Can anyone unmute themselves and they can know what you understand from this first line?
This says diffusion rate of ammonia.
Yes, very good. So diffusion rate of ammonia, it means what value they are given? They are given Na. They are saying that 10 raised to minus 3 kilomole per meter square into second will transfer. They having a one liquid. They having one water in that ammonia is present. Now ammonia will transfer from liquid phase to the gas phase, and how much amount of molecule will diffuse? They will diffuse 10 raised to minus 3 kilomole per meter square. So Na value is given 10 raised to minus 3 kilomole per meter square per second. It means there is a liquid having ammonia, and ammonia will transfer from liquid phase to the gas phase. And very good. I think Aryan is said. Very good. The interface equilibrium pressure. The interface
Hello. हाँ, जैसे आपने तो
equilibrium pressure
લખાવા પડે ને એનું version.
is 660 Newton per meter square and concentration of NH3 in gas phase is gas phase is 5.05 Newton per meter square. Then if total pressure is 101 Newton per meter square, temperature is 295 Kelvin, and D is equal to 0.24 centimeter square per second. Then find out, then what you have to find out? Gas film thickness. Find gas film thickness. And so this is asked, this example is asked in GATE 1991. This is asked in GATE exam 1991. And so what is the picture I would like to say? Here there is an interface. Here is a liquid phase. Here is a gas phase. NH3 will transfer from liquid phase to the gas phase. There is one the film is present where what is the interface equilibrium pressure sorry the interface will present here. So there is a, here the pressure Pi is given, here gas phase P is given, there is a change in pressure will be given. So this is the scenario. This is the scenario is given. Now they ask to calculate film thickness. What is the film thickness? Then this is the ask. What is gas film? Gas film means the for example, liquid is stagnant here. What I would like to say here, liquid is stagnant. The gas is flowing around it. Gas is flowing. So there is a boundary layer between gas film to the liquid film. So gas is flowing, liquid is stagnant. So whenever one phase is flowing, at that time there is a boundary layer between the gas and liquid, and where the pressure is changes here. So this is the gas film. Gas film means the film near to gas phase. Can you do it your own? So what we have to use, I will give you the equation. Na is equal to K multiply by delta P, where delta P is equal to K delta P. Okay, so Na is equal to DAB divided by thickness of the film PAI minus P. Na value is given, DAB value is given, PI value is given, P is given. Here is a PI and it is P. Total pressure we don't have to consider. This pressure we have to consider. 660 minus 5.05 Newton per meter square. Now where sorry, here delta P will be there. Sorry, we have to use this equation because here this will use for concentration. Let me correct this again. Here it is used for concentration. If you want to use for gas phase, then we have to add like this. We have to use add like this. Na is equal to K divided by RT delta P, because it is in concentration. If you want to use in pressure, then we have to use PV is equal to nRT. So K divided by RT multiplied by P, where K is equal to, where we can use K is equal to DAB divided by density thickness multiplied by RT multiplied by delta P, Pi minus P. So can you try your own? DAB is given, uh, R is given, T is given. This we have to find it out. Delta P is given, 660 minus 540. Na is given. So only remaining is the thickness.
Sir,
Yes,
sir, P is a 5.05 or 505?
5.05. It's a
Okay.
5.05. It's a 5.05. So 10 raised to minus 3. Anything you want to change? DAB 0.24 centimeter square per second. So we have to convert it into the meter square per second. Is equal to 2.4 multiplied by 10 raised to minus 5 meter square per second divided by R 8.314 multiplied by T temperature. How much temperature is it? 295 Kelvin multiplied by 660 minus 5.05 here multiply by thickness. So all things is given except thickness. So what will be the thickness? Okay, here 8.314 will be the unit of kilopascal meter cube per kilo mole into Kelvin, and Newton per meter square is a Pascal. So this one is Pascal, this one is Pascal, but 8.314 is in kilopascal. So we have to divide by 1, divide by 1000. Huh? Again, I am saying Newton per meter square is a Pascal. Then so this one unit is in Pascal. This one unit is in Pascal. But 8.314, what is the unit? The unit is kilopascal into meter cube divided by kilomole Kelvin. So here kilopascal will be there. So we'll convert into the 1 kilopascal is equal to 1000 Pascal. So we'll divide by 1000. So whatever the answer will come, it is answer will come in meter. So we have to divide by 1000. So because of unit consistency, we divide by 1000. Anyone having answer in meter, and we can also say that in micrometer. Both are acceptable. Okay, very good. Okay, 66.24 centimeter. Okay, very good. Someone, Aryan will be 66.24 centimeter. Okay. Why it is given in total pressure? Okay. Let me tell you why it is given total pressure. I change the example in easiest way. For example, if they are saying that therefore I am giving the answer. Concentration of NH3 in gas phase is, for example, okay, they are not saying 5.05 multiplied by Newton. If they are saying that 5%, if they are saying that concentration of Na3 in gas phase is 5%, so now how will you calculate uh, 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 5% into the into the uh, percentage into the numericals? So for that reason, at that time you have to use the total pressure. So 5 multiplied by 101 Newton into meter square. So once you do it, your answer will be the 5 divided by 100, 5 divided by 100 multiply by 101. So if you do it, then your answer will be 5.05. So what I will do, I will need an easy task for you. I will not say it's a 5%. I'm multiplying with total pressure and then I'm giving the answer. Because of that reason, total pressure is given. So, anyone would like to give the answer? What will the one answer will consider from 66.24 centimeter, and that's a correct one, and that's a correct one, and it's a correct one answer. So you can convert into the meter, and you can also convert into the micrometer. However, so it's a micrometer or meter. It's a correct answer. That's a correct answer. One more example I would like to give. Now you have to do this example and you can give me the answer. So what is the example? You see it in your screen. The example is asked in GATE 2004. Example is asked in GATE exam and that last in 2004 paper. Pure aniline is evaporating through a stagnant air film of 1 mm thickness. So film thickness is given. The given film thickness is 1 mm at 300 Kelvin and total pressure is 100 kilopascal. Vapor pressure of aniline is 300 at 300 Kelvin is 0.1 kilopascal. Total molar concentration on this condition is 40.1 mole per meter cube. DAB value is given 0.74 multiplied by 10 raised to minus 5 meters square per second. They ask us to calculate the numerical value of the mass transfer coefficient is 7.4 multiplied by 10 raised to minus 3 and what is the unit? So what is the unit? They ask us to say unit. So according to it, what will be the unit of mass transfer coefficient? What will be the unit of mass transfer coefficient? They ask us to calculate the unit of mass transfer coefficient. So let me tell you the hint. What are the things are given? They have said that you have a given of mass transfer coefficient value 7.4 multiplied by 10 raised to minus 3. So they are saying that mass transfer coefficient K value is equal to 7.4 multiplied by 10 raised to minus 3 and they ask us to unit of K. Now K is equal to DAB divided by thickness of the film. What is the value of DAB? DAB value is 0.74 multiplied by 10 raised to minus 5 meter square per second. They are given the DAB value is 0.74 multiplied by 10 raised to 5 meter square per second. Now what is the thickness given? Thickness given is 1 mm millimeter. So we have to convert into the meter. So what will be the happen? 0.74 multiplied by 10 raised to minus 5 multiplied by 1000 divided by 1. So what is the unit? Meter square per second multiplied by mm divided by m. So what will be the 1 meter? 1 meter will be cancel out. So meter per second is a unit of K because here the unit is meter square per second. Here unit is m. So mm will be cancel out. K unit will be the meter into second. So unit will be meter per second. A will be the answer. Anyone having doubt within this example? How this meter per second comes? DAB unit is meter square per second. Thickness unit is mm, meter, centimeter. Here meter, here also a meter. Meter cancel out. So only remaining mass transfer meter per second. So the answer is 7.4 10 raised to minus 3 meter per second. So you say the unit of K. Unit of K is meter per second. And second question. Rate of evaporation of aniline is 2.97 multiplied by 10 raised to minus 4. Units are, what is the unit of Na? What is the unit of Na? They ask rate of evaporation of aniline is 2.97 multiplied by 10 raised to minus 4. So what they ask is to calculate the value of Na. Na is equal to K multiply by concentration difference.
कोण
They ask is to unit of Na. So unit of K is meter per second. Then meter per second. Now, what will be the unit of Ca?
हा
What is the unit
Yeah.
of Ca? Unit of Ca is mole per meter cube.
हा तेच आहे.
So what will be the unit of Na? Can you tell me the unit of Na using this one? Mole per second, mole per centimeter square per second, mole per meter square per second, kilomole per meter square per second. It's a B, mole per meter square into second. Yes, Na unit will be the mole per meter square per second. That will be the correct answer. Very good. Okay, so this is the film theory. This is the film theory. So now next lecture will start the penetration theory. In next lecture, we'll start the penetration theory. And students, I would like to say, whenever we have a lab in next lecture will be our lab. But whenever I'm saying kindly join a lab, then and then you have to join a lab. Okay, question number 1. Question number 1 will be the meter per second. Question number 1, they ask the unit, it's meter per second. Now students, I think all students are present. No one is absent. So no need to take attendance. And all students are present. Now you can leave the meeting. I think all of you are present. Now you can leave the meeting. Okay, you take your time. You take your time, Alex. You will go for luncheon, canteen, and then we'll start after 50 minutes to 60 minutes. Then you will take your time for lunch, Alex. Okay, students. So I end meeting here for all of you. I will meet in next lab. Whenever I will write down in whenever I say in your WhatsApp group. So I end
Yes, sir.
meeting here for all of you. Yes, Aryan, you are saying something? Aryan?
Attendance, sir.
Attendance all present. Attendance, no one is absent. Full presence is there.